So, continuing from where we left off in chapter 4, we're going to talk about measurement concepts. So, how you choose to measure the variables in your study and the issues that can arise when you try to measure things. So, one thing that you probably don't think about a lot is how different things are measured. So, let's talk about height, right? How do you measure someone's height? You might think about like maybe feet and inches. That is one way of measuring somebody's height. You could describe them in a category. Is their height average? Are they tall? Are they short? Maybe you might compare them to other people, right? You might say, oh, this is my tallest friend. This is my shortest friend, right? And then I have one friend who's right in the middle between them. So, depending on how we decide to measure something, the depth of the information you have is going to change. So, for example, if I know that my friend is 6'2", and I know that all my other friends are 5'10" and shorter, then I know that my friend is 6'2", and I know that he's the tallest friend. Now, if I just know that my friend is my tallest friend, but I don't know how tall they actually are, right? Then I actually don't know how much taller they are than all of my other friends. Before, I knew that one was 6'2", the other was 5'10", so I know that there's a 4-inch difference between my friends, right? If all of my friends are tall, so I just categorize them as tall people, then even less so than before, do I have the ability to kind of differentiate between them, right? If all of them are categorized as tall. So, how I define things is really important. Think about grades, right? How do you represent your grade? Well, you could represent it as a percentage, right? Or you could represent it as a letter. So, if I have a B, and I want an A, well, how close am I to getting an A? If you just look at it as a letter, I'm right, I'm real close, right? I'm almost right there. The next grade up is an A, but if I look at it as a percentage and I say, well, the percentage I have is an 81 and I'm trying to get an A, which is a 90, well, I'm going to have to work really hard to close that gap. So, depending on how we define things, we could have more details or we might have fewer details. So, determining how we're going to measure a variable, especially as you're designing a survey to get information about a specific variable, is super important. So there are different types of measurement based on how specific you want to be with your measurements. So we have four what are called scales of measurement, right? The further down you go down this scale, the more complicated the data becomes, right? Or in this case, the further up you go. So the basic type of measurement is what is called nominal. It's categorical. So essentially, what you're doing is you're just saying, hey, these two things are different, right? So I go to my refrigerator, there is a Coke, there is a Diet Coke, there is a Coke Zero, right? Those are categories. I'm not saying one is better than the other, I'm just saying that they are different. Now, if you asked me, Professor Thompson, well, out of the three, which is your favorite? I would say, well, Coke is my favorite for sure. And then I guess Coke Zero and then Diet Coke, right? So that introduces what is called magnitude. It's an ordinal scale. Ordinal scales allow us to understand the order of things, right? Order. So by putting them in order, we're able to say that some things are greater or less than other things. That's what magnitude means. Now, the thing is, let's say you're finishing a race, right? You have somebody who finishes in first place, then second place, and then third place, right? So, is the difference between first and second place the same as the difference between second and third place? So the answer is I don't know, right? You don't know for sure. All you know is that first was first, second was second, and third was third. It could have been first and second over here, and then third lagging behind, right? So here's a little finish line for you. There you go. So ordinal gives you magnitude. It allows you to understand the order, but it doesn't tell you by how much, right? So I have a whole bunch of friends. One's the tallest, one's the second tallest, the other's the third tallest, right? What's the difference between them? Is it half an inch? Is it 7 inches? Who knows, right? Now, once you have an interval scale, you introduce what are called equal intervals. This means that the differences between them are equal. So if you think about like rating something on a scale from 1 to 10, how much are you enjoying this lecture? Well, one person says 5, another person says 7, and another person says 9. The difference between the person who said 5 and 7 is the same as the difference between the person who said 7 and 9, right? We're assuming that those intervals are equal. The great thing about equal intervals is it allows us to do simple math. So we can actually add scores together. So if I asked you, are you enjoying the lecture? Are you learning things? Do you feel like I'm giving adequate examples on a scale of 1 to 10? Do you like me as a person? Do you think my mom would be proud of me on a scale of 1 to 10, right? So I can take, you said 5 and then 7, then you said 5, and then you said 3, and then you said 10, right? I can add those together. What's that, 32, right? And so I can actually compare your score to someone else's. And I can see between the two of you, right, who is enjoying the class more. So interval measurements are actually really important because you can use quantitative data. These lower ones are just describing things. With this, you can start doing math, right? So the thing that ratio introduces, so it has magnitude. You can tell that things are greater. It has equal intervals, right? So you can actually start doing addition and subtraction, but it has what's called a true or absolute zero. That true zero is very important because it allows you to do multiplication and division, right? So so let's say I had a scale of measurement, and I was like, how much do you enjoy the class, right? On a scale of -5 to +5, and 0 means, like, I can take it or leave it, right? It's not my favorite class. It's not my least favorite class. That's not a true 0 because 0 in this case doesn't represent a true absence of something, right? Or think about temperature. When you're looking at the thermometer and it says 0 degrees, let's say Fahrenheit, right? That doesn't mean that there's no heat, right? It can get actually significantly colder, right? So now let's say I look at my bank account, and so I have B of A, and it says $0 and 0 cents, right? That actually means that there is no money in my bank account. That is a true 0. So if a measurement can have a true 0, if 0 actually means the complete absence of something, right, then you can do math, although you can specifically do multiplication and division. So once again, nominal variables are categories, right? So we have all the Pokemans, right? These are the Pokemans. You can see that these are Pokemans. I think that's actually a Digiman, but all these are Pokemons. So I only said that to make some of the nerds angry. I'm actually super cool. I caught all 150. That's all there are. There have never been any more than that. So get out of here. You fairy Pokemon, get out of here. You don't belong here. Only the originals. Why? Whatever, it's fine. I didn't look carefully at this photo before I chose it. The so categories allow you to differentiate between different things, but it's not necessarily saying that one thing is greater or lesser, right? So this is a Snorlax, this is a Venusaur, this is a Gengar, and this you thought it was a Ditto, but it's actually a Ditto in disguise as a Ditto. Some of you are like, what are Pokemon? What is this? And I just made one of you real happy. So it's a balance, right? I can't make everybody happy in every lecture. I'll try one of these days to make like a cool sports reference. Baseball scores. There we go. But yeah, baseball teams are nominal, right? Even though we might believe that our team is greater, we are saying like these are the Cubs, these are the Dodgers, these are the Lakers, these are the Raiders, right? Different baseball teams. There you go. I made the nerds mad. I made the sports people mad. Everybody's mad at me now. Gender, nominal, right? Hair color, brands, types of pets. Do you like cats, dogs, lizards? All those things are nominal. Again, we're not saying that one thing is better than another. All we're doing is categorizing. Then we have ordinal. Ordinal is a ranking scale. An easy way to think of this is like spiciness, right? So mild, is less spicy than hot, which is less spicy than fire, which is less spicy than Diablo, right? The difference between fire and Diablo isn't necessarily the same as the difference between hot and fire. It's also not necessarily the same as the difference between hot and mild, right? We just know that if you're, putting hot sauce on your food and you're like, I want something spicier, right? You know that these two are going to be more spicy because it's an ordinal scale. You don't know by how much it's going to be. But if you're like, I want something that's a little bit spicier, you'll probably go to fire because you know that fire is less spicy than Diablo, right? The so magnitude is important because it allows us to say this is more, this is less, right? But we do not clearly know by how much, right? For those of you who play video games, that's difficulty level. So if you've been playing on normal mode, and then you're like, oh, I think I'm ready for hard mode, and then you're like, oh, like it's just incrementally more difficult. Like you start the game and then all of a sudden like you're one hit killed by something. That is an example of an ordinal skill, right? The difference between casual and easy and normal and hard, right? Aren't necessarily, you're not seeing the same amount of difference. It could be this difference from one to the other, then this difference, and like a huge leap in difficulty, right? Military rank is the same. You know that this higher rank is higher ranked than this one, but the differences between ranks aren't the same amount. You just know who outranks who. Same thing with letter grades, right? I have one student with an A, another student with a B. Who had the higher grade? The student with the A. But by how much? It could be by 19 percentage points, right? If this person has an 80% and this person has a 99, or it could be just by 2 if this person has an 89 and this person has a 91. I just know that the person who has the A did better. So ordinal scales, you only have magnitude, but you could never tell by how much. So with an interval scale, you can see something like this pain scale. When I use the image, I didn't realize that it had a 0. So just ignore that 0. Imagine it's 1 to 10, right? This is an interval scale. The difference between 1 and 2 is the same as the difference between 2 and 3, right? Now, because there's no zero, remember, we're just going to ignore that. There's no true zero. So it's a Likert, or sorry, it is a interval scale. Once we put that zero in, and this represents a complete absence of pain, then we might be able to say, oh, this is a ratio scale, right? That true zero really is important. So when you're looking at something like temperature, right? One thing to think about if you're trying to determine whether something is interval or ratio, does multiplication make sense, right? So, for example, let's say uh, a few months ago it was 40 degrees Fahrenheit, and now it's 80 degrees Fahrenheit, right? So that's 80. So 40 degrees Fahrenheit is pretty chilly, right? So is 80 degrees twice as chilly as 40 degrees? Or is 40 degrees half as hot as 80 degrees, right? That doesn't make sense. That is not how we describe temperature, because 0 degrees Fahrenheit or 0 degrees Celsius is not a true zero. You can actually get much colder than that. Now, some of you are probably wondering, well, what about Kelvin and absolute zero, right? Well, in that case, zero means the complete absence of heat, right? So that's why specifically I specified Celsius and Fahrenheit. 1 to 10 scales, temperature, also the Likert scale. You've probably seen this before. Strongly disagree, disagree, neutral, agree, strongly agree. We're assuming that these differences between the categories are equal, so there are equal intervals, right? So that means that you have an interval scale, but there is no zero on that scale, so there's no true zero. So that is the interval scale. And then finally, we have the ratio scale. Ratio scales are our normal measurements. Whenever you're thinking of measuring something, usually it's a ratio scale, right? So maybe you're doing some cooking and you need a tablespoon of salt, right? Or a gallon of water. I don't know how cooking works, but those are all ratio measurements, right? If you ask for 0 tablespoons of salt, you have no salt. There's a true zero. If I have 0 gallons of water, I have no water, right? And multiplication makes sense. If I have 1 gallon of water, and then my friend has 5 gallons of water, they have 5 times as much water as I do, right? So all the normal measurements, height in inches or feet, right? Weight in pounds or kilograms, the amount of money in your bank account, the number of items that you own, right? If somebody asks me, oh, how many gaming consoles do you have? I might say, too many. I'm a big old nerd. Let's just say 5. Let's just say 5, so you guys don't think that I'm super nerdy, but it's significantly more than that. It's dumb. Now I have a friend who's actually more nerdy than me, and they've got like the original Nintendo and like things like that. So they might have 20 consoles in their home, right? So that person has 4 times as many as I do. I have another friend who doesn't play video games at all, and they have 0, right? Meaning they have no consoles. So, really, with ratio, if you're trying to figure out if something is ratio, look at that 0 and see if that actually represents a complete absence of something. So, reliability is the consistency or stability of a measurement, right? So, the when talking about reliability, think about stepping on a scale, right? If you are stepping on a scale, you're hoping that it's going to give you a reliable measurement, that it's not going to fluctuate in the results that it's giving you. Imagine stepping on and then it says, your weight, and then you step on again, and then it adds 30 pounds, and then you step on again, and it subtracts 100 pounds. That's not a reliable measurement. In the same way, when you take a test, you're hoping that the test is reliable and will give consistent results, right? If you don't want to take like an exam for a class, then go, oh, you know what? I think random error made it so that I didn't do as well, right? You want it to give you the same score consistently. So when we're measuring something, we're always trying to get to a true score, right? And so, but there's always some degree of measurement error. So we're always somewhere around that true score, right? So let's go back to an exam that you're taking. You normally would have done well, but you were super sick, right? So your brain was a little foggy. Or you normally wouldn't have done well, but you guessed on a couple of them and you actually did better because of some lucky guesses, right? So that difference between what your true score is, what you should actually get, and all these things that affect it are going to affect the reliability of a measure. A reliable measure is going to control for these things as much as possible. So if you are going to the doctor to get weighed, right? They're going to say, hey, they might ask you to take off your shoes. Actually, most of the time they don't ask you to do it anymore. They don't care. But if you were wearing like a heavy backpack filled with bricks, they would ask you to take that off so that it's a consistent measure, right? So reliability is really important, and we're going to talk about a few different forms of it. So test for test reliability is kind of what I was just referring to. So that's the idea that if you take the same test over and over, you should get the same results, right? Let's say I took the Harry Potter sorting house test. So I was trying to figure out if I was a Gryffindor or a Ravenclaw or a Hufflepuff or a Slytherin, right? If I take the test once and it says I'm a Ravenclaw and I take it again, it should say that I'm a Ravenclaw. But this second time it says I'm a Hufflepuff. This other time it says I'm a Slytherin, and now I'm a Ravenclaw again, and now I'm a Gryffindor, right? That means that it's not a reliable test. That was my cat complaining about issues with reliable tests. So get over here. Oh, hi, buddy. So the any test, if taken multiple times, should give you the same or similar results, right? Imagine if I gave you, if you took your exam twice in a row, right? Just back to back, right? With no break in between. If you take the same exam twice in a row, you should get comparable results. Now, maybe you guessed on a couple questions, right? So the results might be different. Maybe you got a 87 on one, and then you get a 91 on the next one. But overall, your results should be the same. If your results are drastically different, right? The first time you fail it, and then right afterwards you take it again with no break, no ability to check your answers. You fail it, and then you take it again, and you get an A, right? Then that's not a reliable measure. So test for test reliability shows us whether something is reliable by showing us, well, if it's reliable, you should be able to give the same test to people and get similar results. There's also what's called alternate forms reliability. So sometimes you'll have a professor who has different forms of the same test, and you would hope that regardless of what test you get, you're going to get a comparable score, right? So if one version of the test is significantly easier than another version, then that's not a reliable test, right? If I get a B on one version of the test, I should be able to get a B on another version of the test. So different forms, different versions of the same thing should give you the comparable results, right? Sometimes some tests will have whew, short form version where you'll take a 100 question survey and condense it into a 20 question survey. And those have been tested and normed so that you can actually get comparable results with just the short version, right? So that is a form of alternate forms reliability. Different versions of the test give you comparable results. So there's also what's called internal consistency reliability, which is, do the parts of the test relate to one another, right? So imagine you're taking an exam and there are 20 questions, right? 5 questions are impossibly hard. 15 questions are moderately, like if you studied a little bit, if you've been in class, you'll be fine, right? And then those 5 that like almost nobody in the class got right. So that means that there's low relationship between those questions and the rest of the test. There's not much internal consistency. One way of looking at internal consistency is what's called split half reliability, right? Where you look at one side of the test versus another side. So let's just say I have an exam that is part essay and part multiple choice, right? If somebody gets an A on the multiple choice, what would you expect them to get on the essay? Hopefully an A, right? It would be really weird if you got a C on the essay, but an A on the multiple choice, or people did really well on the essay questions, but did terribly on the multiple choice, right? There's low internal consistency. There are a couple other ways of looking at them. You don't need to be too concerned with the details of these, just kind of get the idea. We have Cronbach's alpha and the item total correlation. And both of these basically look at how one question compares to all the other questions on a test. The Cronbach's alpha gives you one big number for the entire test. The item total correlation allows you to see how each question relates to other questions on the test, right? So the split half just cuts the test in half and compares the two sides. Cronbach's alpha gives you a score of how consistent your test is, and the item total correlation allows you to see how every question relates to all other questions on the test. So a way of thinking about this is, if I get the first question correct, it should mean that I'm much more likely to get other questions on the test correct, right? If my scores on one question do not relate to scores on other questions, there's low internal consistency because the questions don't relate to one another. And a test that is measuring something should have questions that relate to one another. So one thing that you should know is that all of your assignments are graded by TAs. I have 2 TAs. One person is, I mean, it doesn't really matter, right? Why should it matter? One person is kind of mean. They're just kind of like a mean person. And, they had a really tough grad school experience, and they feel like you should also be treated like grad students, right? So they maybe, I don't know, they're a bit of a tougher grader. I have another TA who's like just the nicest person you've ever met, just the sweetest person you've ever met, like just so kind, so patient. Like they're the type of person who, if like they get the gist of what you're saying, they'll give you full credit. Now, which person do you want to grade your papers? Some of you are like really sadistic or masochistic, and you're like, oh yeah, I want the tough person, right? Now, uh, realistically, it shouldn't matter, right? Two different people grading the same thing should be able to give consistent scores. But sometimes this isn't the case, right? Or let's say, I have 2 different people monitoring problematic behavior in a classroom, right? And one person is like, oh, that person pulled out their phone, you know, got to check that for problematic behavior. And another person's like, people pull out their phones. Maybe they're just checking the time. They don't mark that as problematic behavior. If different raters are scoring things differently, then you don't have a consistent measurement scale. This is what's referred to as inter-rater reliability. There's also something called intra-rater reliability. So just think about it like this way. I'm grading your papers one night after I just won, like maybe I got like 3 numbers in the lottery and I got a couple $1,000. So I'm in a really good mood, right? A week later, I'm grading some papers and I just got broken up with. So I'm in a really terrible mood, right? Ideally, my mood should not affect your grade. And that would mean that there's high intra-rater reliability. But sometimes that is an issue, right? Maybe the paper, if you turn your paper in first, right, when I have a lot of energy and I haven't read a lot of papers before, I'm going to like really be more lenient. But then by the end of it, I'm just like angry at everybody. I'm like, I said it in the instructions that they didn't read it, right? And then everybody, the last 15 people who turn in their assignments get lower grades, right? So my rating is inconsistent. Before we talked about validity, then just now we talked about reliability, and now we're going to bring the two together. So validity is about accuracy, right? There's a specific thing that we're trying to hit, and we're trying to make sure that we hit it every time, right? If I'm not accurate, then I'm hitting this and calling it the bullseye, right? That's validity. I want to actually hit the thing that I'm trying to hit. Now, precision is a matter of, can I get the same target hit multiple times, right? So I can have something that's reliable and it might not be valid, right? So that would be something that is precise, right? This is a really good measurement tool, but I'm actually not hitting what I'm trying to measure. That's an issue, right? Or I might have something that isn't a really good measurement tool, but kind of gets close to what I'm trying to measure, right? It's close enough. That's not great either. So low reliability is going to affect your validity, right? If you don't have a precise measure, you can't have an accurate measure. The worst case scenario is to have no precision and no accuracy, and then everything just going everywhere. What you want to have is a balance of reliability and validity, where not only are you close to the target that you're intending to hit, validity, but you're also precise, right? And you're getting that same score every time. So precision and accuracy, reliability and validity. We talked about construct validity before, but I just want to review it. It is the adequacy of your operational definition. So if I say that birds are four-legged creatures with triangle ears, claws, and a long tail that use the bathroom in a litter box, this is a bird because that is my operational definition. Now, is it a confusing definition? Yes, it 100% is. But if I clearly define something as something, then I know that that is what it is. So if I say bird and you think flying thing, right? Well, that's my problem because I didn't clearly define what I was talking about. So you want to have a clear operational definition so that everybody can understand what you're actually measuring. Then we have content validity. Content validity is a related term. Essentially, based off of your construct, are you representing all parts of that construct equally in your measurement tool? So let's say we had a 5-chapter exam on chapters 1, 2, 3, 4, and 5. If you took the test, right, and there were only questions from chapter 3, you'd be a little bit disappointed. You'd be like, how is this an exam covering chapters 1 through 5 if all the questions are covering chapter 3, right? Or let's say you were measuring healthy behaviors, right? And they only talked about eating and diet, but they never talked about exercise or healthy relationships or minimizing stress, right? That would be a really poor test of healthy behaviors because it's only focused on one specific thing. Now, if if the construct is healthy eating, then that's okay. But if you have a construct, you want to make sure that all parts are being represented equally, right? Then we also have face validity. Face validity is a bit of a weird one. It's essentially the idea of being able to look at a survey and being able to tell what's being measured. So let's say I dropped my exam for one of my classes, right? You pick it up and then you say, oh, is this an exam for biopsychology, right? And then you see questions about neurons and neurotransmitters and glial cells and the mitochondria, right? That is a face valid test. If you look at this test, right? So the text might be a little bit tiny, so I'll read some of the questions. Yelled at others when they have annoyed you, reacted angrily when provoked by others, had temper tantrums, damaged things because you felt mad, gotten angry when frustrated, hurt others to win a game, used physical force to get others to do what you want, gotten angry or mad when you lost a game, threatened and bullied someone, right? Never, hardly ever, sometimes, often, almost always. What do you think that test is measuring, right? Taking things from other students, had fights with others to show who was on top, right? Uh, Vandalize something for fun. This is measuring aggression, right? So a face valid survey, by reading it, you can tell what it's about. Now, sometimes you don't want a face valid survey because you don't want people to know what you're measuring, and that's a whole other thing. But face validity just refers to the ease at which you can tell what something is measuring, which is makes designing a survey pretty easy because you can look and say, well, uh, temper tantrums, that's related to aggression, right? Put in the survey. Had a gang fight to be cool, that's related to aggression. Or, well, I don't know. Is that, I mean, fighting is aggressive, but maybe I'll change it to just had a fight, right? So the uh, having a face valid survey allows you to very easily see what's related to your construct. Then we have predictive validity, which is whether or not a test can predict some future event, right? So SAT, uh, uh, I almost said SAT test, the SAT or an AP exam or the GRE, all those exams don't actually look at what you currently know. Well, they do. But the purpose of them is to predict how you would have done in some future thing, right? So the SAT tells you what your first year GPA in college, or sorry, first semester GPA in college is likely to be, right? Higher SAT score means that you're more likely to do well in college. So the purpose of the SAT is to show basically, well, if this person does well, then we should let them in our college because they'll do well at least their first semester. Or think of like a fertility test, right? You're taking the test to determine whether or not you're likely to have a child in the future, right? So predictive validity is one side of the coin. The other side is what we'll talk about next, which is concurrent validity. So concurrent validity shows something that is happening right now, right? So think of an STD or an STI check, right? You're trying to see if you currently have an STD or an STI. You're not trying to predict whether you'll get one in the future. No one knows. But also be very careful because in 2 months you will get chlamydia. But an STD check, you're checking to see if you are likely, if you currently have the thing. Now, think of a pregnancy test, right? So before we talked about fertility tests, pregnancy tests tell you if you are pregnant right now. Fertility tests tell you whether or not you are likely to become pregnant in the future, right? Pregnancy tests, you're looking for high concurrent validity. Fertility tests, you're looking for high predictive validity, right? So some tests, you're trying to measure something as it's happening right now. Other tests, you're trying to predict some future thing, right? The reason why we measure cholesterol is to predict your likelihood of having some cardiovascular issues later in life, right? So we control those cholesterol levels now to prevent something from happening later. So the test does have concurrent validity, or hopefully does, where it tells you what your actual cholesterol looks like, but it also should have predictive validity by telling you how likely you are to develop heart disease. So our last two types of validity are convergent and discriminant validity. Convergent validity is the idea that things that measure the same thing should have comparable scores. So think about this. You are taking my Sci 203 class. There are other teachers that are teaching the same course from the same textbook, right? There are teachers around the world, or maybe just around the US, who are teaching from the same textbook. Even though we all have different tests, right? I write my own tests, other teachers write their own tests. If you took another teacher's test, you should get comparable scores, right? Scores on my test should relate to other tests of the material in this class. So things that measure similar things should give similar scores. If I create a new test to measure depression, it should be related to all the other tests that measure depression. Now, if I make a test for Sci 203, it should not be related to a test that measures depression. That is what we are going to talk about next, which is discriminant validity. So my brain, whenever I talk about convergent validity, my brain always is like, oh, the opposite of that is divergent validity. It's not. It's discriminant validity. So when thinking of a picture, a picture. Can I say the word picture? Yeah, there we go. That's how the word is said. When trying to find a picture, I was like, oh, this is funny. Maybe it's funny just to me. Maybe you don't remember this classic film Divergent, where I saw the first two and then forgot that there were other parts to watch. So I actually don't know how it ends. I'm just going to assume that everybody's happy. So do not tell me how it ends. Discriminant validity is the idea that tests that measure one thing should not be related to other measurements that are unrelated, right? So how well you do on the exams in my class shouldn't be related to your weight, shouldn't be related to your Harry Potter house. They should not be related to how well you do in I don't know, like a improv class. All those things are different things. So if my tests were related to how depressed you are, and the more depressed you are, the better you do on my test, then my test might not be measuring your knowledge of this class. My test, weirdly enough, might be measuring depression, right? So scores on one test should not relate to scores on an unrelated measure. It seems straightforward, but it's an important consideration because this is a good way of making sure that you have a clean and good construct, because you want to make sure that you're not including other third variables that are mucking up your measurement. So that is chapter 5. Make sure you review all the types of validity, all the types of reliability, and make sure that you really understand those scales of measurement: nominal, ordinal, interval, ratio. If you are having trouble remembering those, you can think no ear, right? If you don't speak Spanish, then you think I'm talking about the part of your face, no ear, right? Don't go there. Nominal, ordinal, interval, ratio, or if you parlez vous français, then it's noir, which is somewhere here. Can you see? Yeah, that's black. There we go. So the uh, so remember those, remember the differentiating factors. Really make sure you understand the differences between those and you get the general idea of what they are, because that specific thing is going to come up over and over and over. We're going to have a homework assignment that deals with that to get you some more practice, but make sure that you're also practicing. It is one of the things that students get hung up with the most. So practice those scales of measurement. Find a couple extra YouTube videos if you need to. That will help drill those in. If you have the book, review the book. Really just make sure you understand the differences between those 4 scales of measurement. Okay, that is it. You have a good whatever time of day it is: morning, night, noon, twilight. You enjoy it. Take care. See you in the next chapter.